Hi, I'm Nick Bowers. My project is the effect of American oysters in the Chesapeake Bay on various water quality measures. So the reason I'm doing this is because I really like oysters, and the Chesapeake has been hit hard by oyster farming. The oysters are a great resource for the Chesapeake Bay because they filter the water out. That's the way they feed. And they filter out the debris and some of the bad stuff in the water. Back in the colonial times, the oysters could filter out the whole bay's worth of water in 3 days, whereas now the oysters take over a year to filter out the same quantity of water. So American oysters live all across the east coast of North America and northern South America. The Chesapeake Bay is a large and complex ecosystem. It's home to many animals and plants, so it's important to conserve this resource, and one of the ways to do that is to put more oysters out there. And so what I was hoping to find is what each oyster's effect on dissolved oxygen, pH, and turbidity was, so that conservation groups could find a realistic goal for conserving the bay and to know the effect that each oyster has on the bay. For measuring dissolved oxygen, I used a test kit like this. So the sample of water goes in this graduated cylinder, and then this ampule, the tip is broken off into it, and so it fills up to about here with water. And then after a few inversions, the color starts changing, and then you can measure the color difference against one of these to see the parts per million for dissolved oxygen. And that's how I did it there. For pH, I used a probe. So just take off the cap and stick it in the water, and you got it. There is a buffer solution, which I used at the beginning of the experiment to calibrate it. Then for turbidity, I used this turbidity tube, which is a fluorescent light bulb tube with the cap at the end. I just duct taped it on. And then I used a ruler to mark some of the measurements on the side for important values of NTU. And it's not a linear scale, it's a logarithmic scale. And so the higher you get, the smaller the more space between the numbers. The water is placed into the tube, and then the height at which the black and white disc disappears from vision is when you know that you've got your measurement. After the research I did, I came to the hypothesis that if the effect of oysters on Chesapeake Bay water's pH, turbidity, and dissolved oxygen are tested, then the oysters will have the greatest effect on the water's turbidity. They'll also affect the dissolved oxygen, which is what I came to in my research, because they're a living organism and they need oxygen, so they're most likely going to use the oxygen. So how I set up the experiment was I had 3 tanks just for time's sake, and I put 5 oysters in each of the tanks. I measured the water's pH, turbidity, and dissolved oxygen before the oysters went in the tank, and then an hour after the oysters were placed in the tank, I measured all these measurements again to see their new values. So I did this 7 times, 5 oysters in each tank, and what I came to was that the oysters didn't have any effect on the water. So for pH, all of my values were around 8.3. For dissolved oxygen, all of my values were 10 parts per million, and all of my values for turbidity were around 3 NTU. And I have several theories about this. You can see the bar graph for averages. What I did to calculate the data table in the bar graph I converted the logarithmic scales of pH and turbidity into linear scales, turbidity based on centimeters high instead of NTU, and then the actual amount of hydrogen ion concentration for pH instead of the actual pH scale, since they're logarithmic. And then once I calculated their linear values, I divided the new by the original and subtracted 1 to get their decimal change so that it would be a more accurate measurement. But it basically just says that there is no effect. So the p-values were all well above 0.05, so the confidence level was below 90%. So I can't say that the IV had an effect on the DV. I ran t-tests between the original and the new for each of the levels of the IV. So my box and whisker plot is a little misleading because the values are so spread out in this. The scale is really 1 is right here, and this is the change in from the original to the new. And I didn't do the linear values for this one where I did in bar graph and data table, just because it would have been hard to do that for each specific trial, and it basically just says that there was no effect. So yeah, some of the theories I had as to why the oysters had no effect is because, one, there may have been too few oysters per tank. The reason I used 5 oysters per tank is because in my research I learned that a full-grown oyster can filter up to 50 gallons per day. And when you divide that by 24 hours in the day and then multiply that by 5 oysters per tank, I had thought that they could filter out the whole 10 gallons in the hour that I had. One of the other reasons why I think they had no effect is because the oysters, I had kept them in a cooler for several days before the experiment happened, and some of them may have died, as evidenced by them not opening when they were in the water, which they're supposed to do. Only about half of them opened when they were placed in the tanks. Another reason why I think that they had no effect, especially for turbidity, was that Chesapeake Bay water is relatively clear, about 3 or 4 NTU, and the turbidity tube is not accurate to measurements clearer than 5 NTU. The lower the measurement, meaning the clearer the water. And so I sort of had to estimate on how clear the water was based on the turbidity tube, which is kind of tough and inaccurate. A turbidity probe probably would have solved that problem, but still, if I had had dirtier water, maybe they would have had more effect on the turbidity. I was also surprised that the oysters didn't have any effect on the dissolved oxygen, and that the original and the new values were exactly the same for each trial, because the oysters are living organisms and they use oxygen, so I had assumed that they would decrease the amount of dissolved oxygen in the water. Yeah, so follow-up projects could be testing different types of mollusks on their effect on these water quality measures, like mussels, clams, stuff like that. Another experiment could be to test oysters' effect on different water quality measurements, the ones not listed here, so other than pH, dissolved oxygen, and turbidity.